yourself. Tell us a little about your history, and we'll start from there.
Yeah, so I graduated as a molecular biologist. During my universities, I did DNA work. After I graduated, I had a scholarship from the Hungary Academy of Sciences. At that time, my job was to identify the gene in the bacteria which is responsible to recognize the host plant. And I defended my PhD in 1986. And after the 1988, then I had a scholarship again. And a couple of months later, me and the family moved to the United States because I was invited as a postdoc to Columbia, Missouri, where I also continue my DNA work. And after a year, we came home because I had an idea, even when I was a student, what type of research we should do to solve the cancer problem. So we came home, and next day I quit my former job and try to find another job which is related to cancer research. And this way I started to work at the National Institute of Oncology in Hungary. I worked there 1.5 years, and I started the research with the deuterium depletion and checking out what will happen if we reduce the deconcentration. And the results were so promising that we established the company in 1993. And I told people that we will do the best cancer drug on the world. And after 30 years, I'm still saying that we know how to do the best cancer drug.
Right.
And we are working on.
Well, okay. So I want to qualify a few things. First of all, I want to say that when you, I think that people watching this video should understand a few things. Number one, there's 3 forms of hydrogen: regular hydrogen called protium, an isotope called deuterium, and then a third isotope called tritium that we don't need to talk about. Tritium is radioactive. We're talking really about the most abundant element of the universe, hydrogen, and the 2 versions, and how this heavier version called deuterium is related to cancer. So you were investigating DNA. You were interested before you sort of got into the cancer work. Were you looking at DNA with regards to cancer specifically, or just you were a molecular biologist, you're in biochemistry and you were doing research? Were you seeing anything? Was there any hint of talking about a subatomic particle, or you just had an interest in cancer, and then it was later that you started to think about the subatomic particles?
No, the hints came from Albert Szent-Györgyi, who is one of the Hungarian Nobel laureates. And one of his interviews in the early 70s, when I was a teenager, he mentioned the word submolecular. So he recognized that the life is so complex. And think about that in a nucleus, which diameter is 10 micrometer, there is a 1.8 meter length DNA. It is packaged. So the information is so dense, but it contains everything. And he suggested that it's impossible that huge protein molecules would be responsible to harmonize the 25,000 gene expression and the 2,000 biochemical processes. So the first idea which came to my mind and kept it in my mind, submolecular. And there was a date, it was in 1976, May 21st, when Albert Szent-Györgyi that the electron should be that submolecular particle, which is a negatively charged. And the idea came to my mind that the hydrogen should be that submolecular particle, which is positively charged. And I wrote it down. And at that time, so in 1976, I wrote that the hydrogen ion should be responsible somehow for cancer. And 4 years later, when I was a student, as a molecular biologist, the other idea came to my mind that there's a heavy hydrogen, it's called deuterium. And then I don't know why, but I was 100% sure that these 2 hydrogen responsible to regulate the cell growth, and we should find the key to solve the cancer problem.
Right. Back in those early days, had you heard about, I know there's always people talk about populations that live in the Himalayas or in the northern part of Russia that lived a very long time. and this related to the level of deuterium in the water. Had you heard of anything like that? I know that you're Hungarian and you come from Hungary, and I know that a lot of the deuterium work has gone on in Hungary. But had you been thinking, was that because I know when I got interested in deuterium, I kind of, it's a very mystical, magical, powerful thing. And then I started to hear, there are people who lived a long time because they drank water that's very low in deuterium. Had you heard any of that in the early part? Number one. Number two was everyone was thinking, I guess, about electrons, and then you were thinking that, well, maybe it's protons, and maybe, I don't know. It's these days, quantum biology is very big now. Everyone is starting to talk about electron flow and that. But in those days, why were they thinking electron versus proton? So sorry, that's two questions.
Let's start with the second one. So I think that the electron and the proton is the two different sides of the same coin. So they are coupled. So it's whenever I start to work on hydrogen, electron or hydrogen, we have to come to the same conclusion and to the same results. But when the idea came to my mind that the deuterium has some key role, first I checked the literature, and I went to the library and see what type of data has been published with deuterium. And it was surprising that each paper were related applying heavy water in a high concentration. So, and it was obvious for decades that when we are using D2O in high concentration, it has a tremendous effect on biological system. So the plants will not grow up. So even you can kill a dog with a heavy water over 35% of D2O. And this is what I found. And the real surprising was that nobody investigated the possible role of deuterium, which is already there, which is in the water, in the food, everywhere. And it was even surprising when I checked out, because we always talk about this ppm. So in a normal surface water contains 150 deuterium out of 1 million hydrogen, and this is 150 ppm. But if we convert this concentration to millimole, because when we took a blood test and we get back the results, we can see that the potassium is about 3.5 millimole. The calcium level is about 2.5 millimole. The magnesium 1 millimole, but the deuterium is 12 millimole. So the deuterium level in our bodies is 6 times higher than calcium level in the blood. And the question is, maybe we should investigate whether it has some role in the living organism. And the simplest way is if we remove the deuterium and we see, is there any consequence of that?
Right. So basically, what you were saying is that when we look at deuterium in our water, we measure it by parts per million. So there's one deuterium for there's 155 deuterium atoms per 1 million of regular hydrogen. So it sounds like it's a small amount, so it's 150 ppm. But when we actually look at the concentration of deuterium in our blood, and you do it by concentration, like to the other components of plasma, we find that deuterium is like 3 or 4 times higher in concentration than calcium, than our main minerals that are in our blood. That's kind of a big deal, all right? And no one,
I guess so.
But yeah, no one had really been paying attention to this, right?
Yeah.
Okay, so the other thing is that I know that when I learned about the Krebs cycle when I was taking biology, we see those 10 enzymatic steps. And from what I've heard, the majority or every one of those steps is technically the cycle's ability to take what might be a deuterium atom and swap it out with a hydrogen atom. Is that something that was, when did yourself, or when did we start to think like that? Is that part of this whole process, number one? And the other thing is, I know that some enzymes are, most, I guess all enzymes are designed technically around deuterium to avoid it, right? Unless they want to incorporate it, like something like collagen, which I think is a new understanding. But maybe you can sort of Is that true? Is our biology built around this version of hydrogen?
Yeah. So when we published our very first paper, which based on my research in the National Institute of Oncology, we concluded that, and even before me, it was proved that when a growth hormone binds to the membrane to the growth hormone receptor, that stimulates the sodium hydrogen exchanger. It means that the membrane transport out one hydrogen and pick up one sodium. And before I started my research, it was obvious that everybody accepted that change in the pH, which is the activation of the sodium hydrogen antiport, is a signal for the cell to multiply. And when we published our first paper, we could prove that in tissue culture, the cells kept on deuterium depleted media, we could slow down the cell growth and we could stop the cancer cell growth. And in that case, we concluded that when the sodium hydrogen antiport exchanger is activated because the growth hormone binding to the receptor, that system will prefer to eliminate the hydrogen. So it will be picky.
Right.
Catch the hydrogen, transport it, but keep back the deuterium.
Right.
And our conclusion was that the higher DH ratio is a final signal to initiate the cell growth and not the pH shift. And that was a very first conclusion. And the next question.
Wait. I want to slow you down because I understand exactly what you said, but to anyone listening to this, so what you're saying is that you were looking at cancer cells specifically, but the question is it in normal cells as well? Is the ratio of deuterium to hydrogen, this is a cellular signal for the cell to divide, right?
Yeah.
For cellular growth.
Yeah.
So what you're saying is that when there's a signal of a growth hormone, that's a signal to a cell, hey, conditions are right to divide. So this growth hormone attaches to the cell membrane of a cell, which signals a shift, and these antiporters or these specific protein pumps are going to remove hydrogen and bring in sodium. Okay, so it's going to be an exchange 1-for-1, but that particular pump is selective when it's taking hydrogen in a cell. It really chooses hydrogen over deuterium. So every time you take a hydrogen atom out, there's a more and more deuterium ratio-wise in that cell, and it's that buildup or that higher ratio of deuterium to hydrogen that signals the cell to divide. Now, does that work for regular cells and cancer cells, or is it the same type of reaction? Is that?
Yeah, I guess this is a phenomenon independently whether it's cancer or healthy cells. So the changing DH ratio send a message to the genes and to the proteins and the metabolism, and then that will change. I do not say that each growth hormone binding to the membrane will trigger the cell division. No, it's a very complex system, but when they reach a threshold and all the other parameters are ready to multiply, then the cell make the decision and go from the G1 phase to the S phase. And then they are, at that point, the cell must be sure that they coordinately can manage 24 hours that whole cell division. So and this is the first step. We said that should be the trigger, and this is the minimal requirement that the cell will multiply.
Right. Okay. So then basically, the major discovery, and what the essence of what you're saying is, when there's a lot of deuterium in and around cells, it gives them a greater opportunity to divide. And that technically is aging, but not necessarily aging, it's growth, right? And it doesn't matter where the cells are. For whatever reason, if those cells have a higher concentration of deuterium, they're more likely to go into they're going to divide. And that is technically, cells can only divide so many times before they're done. So technically that's aging.
Yeah, yes, you're completely right. So the probability whether the cell can initiate the cell division is correlate with the deuterium level in the cell and around the cell, and or in the human.
Right. Sounds like pretty important stuff. I mean, so when I read your book almost 7 years ago, Defeating Cancer, and I read it and I didn't understand it. And I read it again and I didn't understand it. I read it and it took me a really long time until I realized just how big of a deal this is. And you can see I've got my hydrogen hat and my deuterium t-shirt. So I obviously think this is important enough to bring it to popular culture. But you had this realization. You said to yourself, wow, this is a really big deal. I'm going to have this great cancer drug. I know the world doesn't work the way we want, but I want to before we talk about some of the experiments you've done, I kind of want to just drill down a little deeper on cancer itself and just to understand. So we have the basics. The basics is you have a cell. A cell is the basic building block of all biology. When this cell has the right amount of deuterium, it's a signal to grow. Now, bacteria, they are single cells. They want to grow all the time, so they should like deuterium.
What we have seen that we could not modify the growth of bacteria in deuterium depleted water, and even they are able to tolerate very high concentration of deuterium. I think that the bacteria is a prokaryote. We are in eukaryotics, we have eukaryotic cells. It's a two big difference. And the big difference is caused by the mitochondria, which was used to a bacteria. So they harmonized and they live together, and that allowed to this original cell to become so complex and could grow during the evolution.
Okay.
And the other part, of course, we can trigger the cell multiplication, but if no break in the system, each cell would divide without any control. But there is a break system in the cell, and it is binded to the mitochondria. Because what the next step, what we said that the water is coming from the water what we drink, and from the food what we burn to carbon dioxide and metabolic water.
Yes.
And that metabolic water is synthesized in the mitochondria. And that metabolic water in a healthy cells is deuterium depleted. And this is a big balance in the cell. The membrane transport can increase the DH ratio, but the mitochondria producing deuterium depleted metabolic water can keep the D level on a low level. And this is the normal way. And why the cancer cell is cancer cell? Because they have a damaged mitochondria.
Okay.
So because they are.
So slow down, because this is really the heart of the matter is why do we get cancer? So whatever, there's going to be an assault on the cell, there'll be some damage. It could be many different things, but ultimately the mitochondria get sick. And once the mitochondria are damaged, the cell should want to kill itself, right? But if too many mitochondria are damaged, the cell cannot do that, and it just starts to grow out of control. Is that the basic understanding of cancer as a really basic theory, being caused by damaged mitochondria? Is that how it works?
Yeah, I guess if we check the evolution, how the cancer developed, it's not related one single gene mutation or another single gene mutation, but as the metabolism is changing and slowly moving, and more and more bad or wrong working mitochondria is in the cell, that can finally results no control in the cell division, and then these cells growing, and then finally the tumor appear. This is one critical step. And of course, the genetic mutation also very important, because a damaged gene can influence the metabolism, and vice versa. They finally intervene, and they can modify the effect and everything.
Okay, so I want to be more specific now. I want to just think about, because this is a discussion that you and I have had. I want to think about either like a skin cancer, like a basal cell carcinoma, or a squamous cell carcinoma. So basal cell carcinoma would be a skin cancer that happens when a cell in the basal layer basically, or one cell or multiple cells start to they become damaged, maybe by lights, maybe by toxin.
Okay.
And now these cells, they're starting to reproduce differently. And as this, and is it the initial assault that kills the mitochondria, so the cell can no longer produce deuterium depleted water, or it can't make enough deuterium depleted water to counteract the deuterium that's in the environment. So normally the mitochondria, through just regular oxidative phosphorylation, the making of energy, will produce as its product water that will come out of the mitochondria. And that's what the cell prefers to use for all its reactions, because it's extremely low or deuterium depleted. But if the mitochondria are dead or dying, they can no longer make this deuterium depleted water. And that's when things really get bad, because deuterium gets into the DNA, causes, misfolding or damage because
Yeah.
Okay.
I guess that the probability whether the cancer appear or not, it strongly depends on the deconcentration. Depends on what we eat, where we live, what type of water we drink, and what is the components of the food we eat, how much carbohydrate, lipids, and proteins, and each together will determine and give a given deconcentration. And the lower the D level, the lower the chance that the cell can multiply, right. But the healthy cells can tolerate that, and it is regulated. But in a damaged cancer cells, it after that very easily can grow.
Okay, so then this is a great moment just to talk about. So you said these are all the things that contribute to your deuterium concentration. It's your diet, the water that you drink, your the food that you eat, your activities. So I know that this is not your area that you talk about a lot, but what you're basically saying is if we're eating a diet that's very low in deuterium, I'd love you to tell us what's low in deuterium. What can people do just sort of as a just to get people to understand, what can they do just to lower their deuterium exposure just based on what you said?
The simplest way is drinking deuterium depleted water, which right. is available, we can say worldwide after our effort and after 30 years. But the food also can determine our deconcentration. And the surprising result was for me when we bought different food in the supermarket, and I asked the guys at the research institute, take out the water from the food, and the dry food should burn to water and carbon dioxide and determine the D level. And we found that the carbohydrate deconcentration is 150, but the fat is 118, or the duck fat is 109 ppm. And it means the more fat we eat, the lower will be the deconcentration of the metabolic water. And I also say that in the human society, the last 60 years, there was a big shift. The fat was said it's bad and cause heart attack and all the thing. And it is suggested eat more carbohydrate, but that way we increase our average deconcentration. And this is the reason I say that so many diabetic patients and so much cancer patients we diagnose every year.
Right. So yeah, because I know it was probably right now, maybe 35, 40 years ago, is we were all told fat is the villain. You have to eat hard, healthy grains. This was a very, very big mistake. And I think that I'm not sure what it's like where you are, but here, even when I mention this to my patients, they all really still believe that fat is bad for you. And their doctors tell them, don't eat red meat, saturated fat is terrible for you. But the things that are low in deuterium would be red meat, the fat of red meat, coconut oils low, maybe olive oil. Yeah, and butter. Butter. Okay, so basically the high fat diet, because people who are going to be listening to this, they may have seen you around before, but the idea is that there's a whole movement, a ketogenic movement, and that people, it's funny when I laugh and people say, oh, that's just a fad that people are going through. I'm like, well, this is probably getting down to the basement level of health, because ultimately, what is it? Definitely it's toxins in your food, a whole separate issue, we can't deny it, but ultimately what makes food healthy or not healthy is the deuterium level. Is sort of that's a general statement. You know, as long as there's balanced nutrition, minerals, and that type of stuff. But you have two foodstuffs. What is this one healthy? Is this one not healthy? This one is very low in deuterium. This is very high in deuterium. Is that the basic equation for humans and animals and life on this planet? Does it work like that?
Yeah, I guess so. Live a life 70 years at 130, 135 ppm or at 150 ppm. At the end of the life, cause big differences, I would say. And this is the reason you mentioned Himalaya, Caucasian, and these people are living on a much lower deconcentration because they are pretty far from the equatorial area and very high altitude, which reduce the deconcentration of the rainwater and the surface water. And that should be a connection.
Wow. Yeah. Okay, cool. So I know that because I have a lot of other videos about deuterium, the details, and now I want to talk just in two different ways. I want to talk about going back to that model of skin cancer, because you can even see, especially my nose, the one I already had removed. When I had my first skin cancer removed, I said to myself, there must be a better way than this. And I don't know that there is, but I wanted to talk about now your work and how you started to experiment. I think you did work on dogs. I want to talk about the deuterium depleted water, and then about like your so just maybe tell us. So I know that your second book, Deuterium Depletion, has a lot of like clinical notes of the different patients that you found. But I'd love you to just sort of maybe tell us some of your best stories of what you decided. So you have this information. We think that cancer is caused or is related to higher concentration of deuterium. It makes perfect sense, follows the laws of physics. How did you take that information, and where did you want to go with that?
Oh, so when we established the company, it was sure, and the biggest challenge is how to manage drug development, and saying people, expert guys, okay, we have a idea how to solve the cancer problem. This is water, and nobody will support you and give you money curing cancer with water.
Yeah.
So very slowly, our aim was to generate more and more data involving more and more scientists and proving from different aspects of the role of deuterium. But one of the most important things was we started to give deuterium depleted water to cancer patients. So it means over 30 years, I followed thousands of cancer patients and collected that type of data. And based upon this data, we could publish with prostate cancer, breast cancer, lung cancer, pancreatic cancer papers. And in that papers, we took a very homogeneous cancer population. Let's say with breast cancer, we divided them according to staging, early stage, late stage, or in remission. And all the numbers, what we could find is we multiplied the median survival time. So, for example, lung cancer population is about median survival time is about 8-10 months. In our case, is 48 months. It means even people with small small cell lung cancer, brain metastasis, lives for 12 years. Breast cancer patients, they were in remission, and this is maybe one of the best way to reduce the cancer deaths. If all the patients who were operated and they are tumor-free, if they consume deuterium depleted water for 3, 4, 5 months every year, that way we should prevent the relapse. Otherwise, very high percent of them relapse and they go back and start again chemotherapy and all these other therapy. So what we are saying now that the deuterium depletion should be part of the oncotherapy. We do not say that we have to replace, because we could find very strong synergistic effect between the targeted therapy, between radiotherapy, much easier to operate the patients if the patients consume 3-4 weeks deuterium depleted water before the operation. And there is strong synergistic effect combining deuterium depletion with radiotherapy. And the reason is that deuterium depletion triggers radicals, and that radicals will trigger the apoptosis. But if at the same time the patient receiving radiotherapy, which also triggered radicals, and this is the reason that they give the radiotherapy, that can result extremely good results.
Okay, so I want to get back just to a little bit more before you could go on the cellular biology mechanism. So let's say we have that. So we have a group of cells that are damaged and multiplying, and these are cancerous or precancerous. Or so as you treat them with the deuterium depleted water, it basically starts to diminish the general concentration of deuterium. As that deuterium concentration goes down, those rapidly dividing cells, this is where I really want to get into detail. So number one, they start to get hydrated with this higher level or this lower level of deuterium. Now, does this allow the mitochondria that are sick and damaged to get healthy enough to cause apoptosis and kill the damaged cell? Or what's the actual steps that you think that happen? Because as you know, if I'm putting deuterium depleted cream on my face, I'm thinking about, well, this water, this low deuterium water is getting massaged into the tissue. So the first, I don't know how many cell layers are being bathed in deuterium depleted water. What's this going to do to the cancer cells and precancerous cells? How long does it take? And then I know there's a component where you stop the deuterium depleted water and these particular cells will die. Maybe you can go into some of that detail, because you know, the information that, you know, you drink water and cancer disappears. I believe you because I understand, but I really want to hear this actual, what is on a molecular level, what happens? Is it the mitochondria? Is it a signal for apoptosis? What do you think happens, or what's your best explanation?
Yeah, so it's clear. So this is a question of dosing, because it depends on what type of cancer, what type of stage of the cancer, what type of conventional therapy, what is the size of the tumor, and so I spent 30 years following cancer patients. This is the reason I wrote the book. I wrote very accurate protocols depending on the type and staging and all the thing. So the key issue is we should reduce the D level as fast that we should trigger the apoptosis. And it means we should induce that radicals that should reach that level which finally enough to trigger the apoptosis. And this is one thing. The other
could you explain this? Sorry. So you're saying that by increasing or by decreasing the deuterium, you're increasing the mitochondria's function, which creates more free radicals, which is a signal for apoptosis, or am I getting that mixed up?
I would say when there is a decreasing D level, then each cell somehow should adapt all the processes to a different D concentration. And the healthy cells can tolerate that because no any side effect, no safety concern. But the cancer cells are struggling to manage this. And for example, of those people, we didn't understand why they are not getting better after consuming the water. Those guys were taking antioxidant. So it means that one way we are going to trigger the radicals, those are taking antioxidants so they catch the radicals and they can negligate and diminish the efficacy of DW. So it is a big fight in the cell whether we can reach the limit, which is enough to trigger the apoptosis. But on the other hand, the cancer cells and each cells trigger the superoxide dismutase and trigger all the mechanisms which is necessary to handle and cope with this increasing the radical concentration. So in general, for example, cancer patients, we recommend to consume 105 ppm, 105 ppm at the one and two first 2 months. And late, so it means there are 45 ppm differences in the D level at the beginning and the water what the person is drinking. But after 1 to 5 weeks, there's a decrease in the D concentration, which means that the change in the D level is decreasing day by day, week by week. And that is not enough after 2-3 months to trigger the radicals. And this is the reason we recommend to change the 105 ppm to 85 and then go to 65, and we can go down to 25 ppm. And to dose it by person, it takes some time. So, and again, this is the reason the book, I try to share the knowledge which was possible, but combining with the conventional therapy, it makes even more complicated. But anyway, this is the way to find the best way, trigger the necrosis. But there is one other process in the cell, because there was a dog we were treated locally with deuterium depleted water, and we took a tissue and we checked it was adenocarcinoma. But 3 weeks later, we took another piece from the tissue and it was adenoma. And after 3 weeks, we couldn't find the tumor, which means that the lower D concentration is going to shift back to the normal. Those cells, they are getting closer to the healthy cells. And maybe one reason could be that the mitochondria also can be working more properly at a lower D concentration. Because what I mentioned in the membrane, the sodium hydrogen, so the mitochondria is prepared for the hydrogen transport system, because the ATPase is transferring the hydrogen through the membrane. And before my very first paper, it was published that the hydrogen ATPase discriminated between the hydrogen and deuterium. So the hydrogen ATPase is very, very picky. They do not choose the hydrogen, choose the deuterium, only the hydrogen. And that again can cause a big change in the DH ratio in the mitochondria, in the two membrane, and so on. So this is how we think about now.
Okay. So, and then, you had also mentioned, so we talked about there was people who the water didn't have as good of an effect for, and those people, what type of antioxidants were they taking? Because I know that right now everywhere is antioxidants. And so basically what you're saying is that the mitochondria was producing free radicals, and we need those free radicals as a signal to tell the cell to kill itself. But if people were taking free radical, something to lower their free radicals, it would decrease the efficacy. Do you know what they were taking? Was it like, do we have any idea?
Vitamin C, vitamin E, vitamin A, selenium, all these things, and people are taking tons of every year.
Okay.
So, and then we do not say that we don't need that type of vitamins, but we say do not combine it with the consumption of deuterium depleted water if you are a cancer patient.
Got it. Okay. All right. Okay. So basically, this is, anyone can get your book. It's on Amazon. And so
Shall I show it? This one?
Yes. Very good. Excellent. And so, I don't think anyone has really heard of this. A lot of people haven't. So when you said this is going to be the best cancer drug, I guess, when we think about therapies, I know that what I came to the conclusion was that the big pharma and the big companies, they want to have something they can patent so no one else can do it. Is that part of the issue with deuterium depleted water? Is that anyone can make it? Well, not anyone can make it. It's harder to make, but is that it? Is that why has this not become more mainstream?
The main reason is, I guess, we have not reached the critical mass. So we are targeting the big pharma, small pharma for 30 years. They have their own business. They are doing it. They are making big money.
Yeah.
And they are struggling because they also has 98% of the phase 2 clinical trial failed. So they are investing billions of dollars, and they failed in the clinical trial. And those who are past the clinical trial, they can increase it 2 months, the median survival time.
Yeah.
So I guess we have a common interest with the big pharma, but we are not already at that stage to take it seriously and combine it, those development with our concept. But on the other hand, I'm pretty sure we must do that. And one day I hope they recognize it, that they have to involve it.
Well, I guess part of the problem, one of the things I like to say is that you can't fix or repair something until you understand how it works and know why it broke down. And I think that there's a cancer industry that has its protocol, and they are all under the assumption that cancer is genetic. And it's not that they're wrong, because I think that, maybe we want to talk about, I know Dr. Thomas Seyfried, he's a guy who really speaks about how cancer is mitochondrial, cancer is a metabolic disease. And what's interesting is that I talked to him a couple of years ago. I did a podcast with him, and I asked him about deuterium, but he said, "Oh, I don't know anything about deuterium." And to me at that time, I wanted to say, well, you're the most advanced person that I've heard of talk about cancer, because I think he's right. We know that if you flood the mitochondria with too much deuterium, mitochondria is going to be damaged, and then that's going to be the impetus for cancer to start, right? But you go further and say that we know that ideally the cancer is a metabolic disease, but because of what deuterium is, it's also a genetic disease, if I'm correct when I say that, because the modifications when deuterium gets where it shouldn't is that it can cause the DNA to change, which makes it technically genetic, coming from the genes. You want to maybe expand on that?
So I think these two approach metabolic disease or genetic disease, both of them right, because none of them and both of them, but the decision is not on a genetic level and metabolic, it's on submolecular level. But I say, so there is a genetic mutation, which is a EGFR amplification. It means that the cells, because the genetic mutation multiply the receptor gene. And it means that much more growth hormone receptor will be in the membrane. So this is a genetic disease. But because there are more receptor, the hydrogen, sodium hydrogen antiport system will work much properly, because much more receptor is on the membrane. So the growth hormone can very easily stimulate the sodium hydrogen, which can easily change the DH ratio to a threshold, and here is the cancer. This is a genetic alteration, but modify the metabolism and the DH ratio, and that leads to cancer. That's it. Wow. And in the mitochondria, there is one gene, fumarate dehydrogenase, one single mutation, and then the TCA cycle will not run. And this is the reason of the clear cell renal carcinoma. So there is one genetic mutation, but because no TCA cycle, no deuterium depleted metabolic water production. So that will very easily change the metabolism, and the cells very easily can lift up the DH ratio, because the mitochondria is damaged. One single gene mutation. So we should forget whether it's genetic or metabolic disease. The decision is made on a submolecular level, and that changing on the submolecular level can be caused because genetic mutation, and can be caused because the metabolism, because by the food, by UV radiation, and whatever.
Wow. Okay. So just to recap that, so you're saying that there's a genetic condition that allows for too many growth hormone receptors on a cell, and because that's the mechanism of deuterium exchange, that those cells become cancerous very quickly, because even just a little bit of growth hormones overstimulates the cell to have much more hydrogen exported and leaving a greater concentration of deuterium.
Yeah.
It's a really fascinating concept to get in your mind around.
And the good point is that the Herceptin is a drug just to cover this growth hormone receptor, and we see extremely good combination and very synergistic effect combining the Herceptin with deuterium depleted water.
Wow. Okay. Very cool. All right. So then, thinking about I still want to go back to the skin cancer. Now, have you done, I know you sent me some research, and you had just very limited, have you done, so is there anyone done research with skin cancer, with deuterium depleted water, either in animals or humans?
I don't know how many, but only a couple of people, because luckily 99.9% of the skin cancer is curable. So this is not a key issue in the cancer field. but what we have, so the most dangerous, of course, the melanoma, which is a skin type disease. And this is the person who has been consuming the water for almost 29 years. In 1994, he had melanoma, and his liver was full with melanoma metastasis. And he started to consume DW for a very long period of time, and he still consuming DW. And he is fine. And he is fine.
Wow. So 30 years later.
Yeah.
And did he have surgery or anything like that, or just deuterium depleted water?
So by the time he came to us in 1994, he was over, because it was diagnosed much earlier and the liver metastasis was over there. And after that, going back to the control, month by month, they could find that, okay, smaller and smaller, the metastasis, and disappeared.
Wow. And so is he drinking 105 parts per million or 110 parts per million, or what's he drinking?
He is consuming 85, but not every day, in the morning and the evening.
Okay, so he's having, like, if maybe he drinks 1.5 liters a day, he's having maybe 1 liter.
Or less. Yeah.
Okay.
But there was another guy with a melanoma, and he was operated and consumed DW, and he was fine, and again came back, repeated. After that, he didn't came back, and he died. And those who are in a remission, if they repeat the cure, they will stay in remission. Otherwise, the tumor can come back.
Wow. Okay. All right. And then so basically you have all your research, and are you trying to make your own products? Are you trying to get your protocol out there? What's your idea? What would you like to see with regard to, what you're working on and cancer, either in the US or anywhere? What's your hopes?
Our hope is from the very, very beginning. We want to register deuterium depletion as a cancer drug. So I cannot imagine anything else, because this is the only way that should be part of the oncotherapy. Now we are applied for investment at the European Union, and we are waiting for investors to support the next clinical trial. Our company has a GMP facility to produce deuterium depleted water for clinical trials. We are selling our deuterium depleted products worldwide, and that generate the revenue and that finance the research and drug development. But the key step would be find the partners, find the investors, complete clinical trials, not one, we need several of them, depending on dosage, different cancer type, to find the best combination with the existing therapy, combining with the deuterium depleted water therapy. And that way, so I calculated the number for the Hungarian population based upon the over 2,000 cancer patients we followed. So in Hungary, every year we lost 33,000 patients because the cancer. And our number says that we can reduce with 25,000 the cancer deaths every year if the deuterium depletion will be part of the therapy.
Now, so in the United States, so I've ordered deuterium depleted water. It came through customs with a special note saying it had a radiation sticker on it. There was all this stuff. Now I kind of laughed at it, because anything associated with deuterium, I think people who don't know immediately start to think about nuclear weapons, right?
Yeah.
So I was surprised. So your company, they ship globally and from your production facility in Hungary?
Yeah.
So I know that you can buy it here. What do you think about? So when you frame it up like this and you tell me that this should be a cancer drug, what do you think about the idea that people can just buy it on their own? It's like you can't go to the drugstore and buy cancer drugs and treat yourself. But here in the US, you can. There's a new I don't know if it's a new company or not, Light Water, and they're selling deuterium depleted water at 10 ppm. Is there a danger if people buy this water and they just drink this? If someone's drinking 10 ppm all day long, is that a danger? And is this maybe something that's going to start to show up with people who have either misunderstood or maybe understood too well, thinking lower deuterium is healthier, I'm going to drink 10 ppm only. What do you think? Because I really don't know the answer to that, but I'm just curious to what your thoughts are and what you're seeing.
Uh, yeah, so it is true that everybody can produce deuterium depleted water because that production is not patentable. It is well known how to produce deuterium depleted water. So one reason I think we need a drug, because that way we can guarantee the quality of the product, and the patients will be controlled, and that way we can get the best results. On the other hand, I also think it would be important to have a so-called functional food, and we should educate the population how to use deuterium depleted products on the market. It takes time, but we have to do that job. But how important the deconcentration? We have done a clinical trial with diabetic patients. And the first thing was that the patients came to me and said, okay, his blood sugar level went down because he was consuming, because the cancer, but was diabetic. And I didn't believe that, but anyway, check it out. So we ran a couple of rat study. So we made the rats diabetic, and we checked whether the deconcentration can reduce the glucose level. And the very first experiment, we used 150 ppm and 25 ppm. And we proved when there is insulin, we could reduce the glucose concentration. But later we checked other ppm, 75, 105, 125, and not the 25 reduced the best way the blood sugar level, but 125. And then we ran another study, 125, 30, 35, 40, 45, and 50. And it turned out that the best deconcentration is to reduce the glucose concentration is 125, 140 ppm. And that is the D level which had my grandfather, who ate the bacon. And this is where the evolution optimized the deconcentration. So, and I say people can drink 10 ppm, but I wouldn't recommend. I think we should reduce it with 15, 20 ppm, the average D level, and keep it there. And that way the metabolism would be better, the glucose metabolism would be better, wouldn't be so much diabetic patients, the blood pressure would be reduced. So we should bring it back as it was for billions of years.
Right. Okay. So we think that the normal level that humans should have is what, like 135 in our bodies? Is that
approximately? Yeah.
Okay.
Yeah.
And what do you think most people are walking around with, depending?
In that study, we checked these 30 people, the blood level, and it was 100, 147, 150.
Wow.
At the end, it was 125, 130.
Wow.
So we could reduce it.
And then do somebody who starts out with a level of 150 or 147 who ends at a level of 120, do they feel different? Do they have more energy? Is there a systemic effect?
Yeah. I typically people getting more energetic, they can run much more. We have done with athletes a loading test, and we could find that the lactic acid appeared later after consuming 105 ppm deuterium depleted water. So the mitochondria, pretty sure, can work much properly at a lower level.
Wow. So do you now I'll ask you some questions out there, because when we were talking before, you told me that people with either esophageal or stomach cancer, the direct contact of the water, of drinking that, sipping that over and over, would decrease the growth of cancer. So there's a topical effect.
Yeah.
How deep do you think? I was starting to try and think about how water gets into cells through aquaporins, and then thinking, if you're bathing an area with deuterium depleted water, how deep in, how many cell layers can topical water get in, do you think? And I don't know if you have,
we never measure that.
Never measured. But like,
so the big difference, for example, if someone got a liver cancer or a stomach cancer, so when someone with a liver cancer drink the water, it goes to the bloodstream and slowly spread everywhere and cause 1-2 ppm decrease in the liver. But those who had a stomach cancer, the water will be just next to the cancer, and there will be a 50 ppm difference in the deconcentration, which is pretty big difference.
Yeah.
So it's very sharply can increase the radicals and can very easily and fast trigger the necrosis of the cancer.
Wow. Well, so because it's the topical aspect that I think is really fascinating. Again, everyone focuses on what's going on, and again, I'm focused with the skin cancer, but so then the idea that wherever you put this deuterium depleted water, it's going to make those cells healthier. Why aren't there 10 creams on the market to put on your face or on your, why is that just because no one has conceptualized that? I know
we had that type of product on the market.
You did?
Yeah, we had. It's very hard to be on the market if you do not finance the sales and marketing.
Right.
Marketing.
Okay.
If you have enough money and push the money to the marketing,
Right.
your products will be bought. People will
buy
it.
It's to me, I mean, this sounds like the most promising thing. I've seen a lot of different things, and I guess the hard part is that I have a very clear division in my mind of what big pharma is doing when they make a drug to treat the symptoms of disease versus going for the root cause. This understanding seems very powerful. So I really hope that this message is going to get out there, and I definitely want to help you. I'm much more interested in sharing just the basic information, because the information, just understanding what a deuterium depleted diet can do, that type of thing, I think is obviously very important. So we're getting to the end of our time, and so I wanted to sort of maybe let you just tell us, what maybe your best results or any closing comments that you want to share with anyone who's listening to this, because I know this is not information you're going to get almost anywhere else. So what would you like people to know? What would what are your closing thoughts?
Relating to cancer and the data and all these things, you mean?
Whatever, because it's a very fascinating topic as more and more people are getting, chronic illness.
Yeah, so I'm pretty sure that we are focusing two indications, the cancer and the metabolic diseases. But we had sporadic feedback disease, which is mitochondria related, Leigh syndrome. Those disease which relating to the central nervous system. Typically, the mitochondria do not working properly, and that cause damage in the whole nervous system. And those who took DDW, they felt better and could give us a positive feedback. No, I just talked to somebody who said that we should check it with autism, those who suffering from autism, and I suppose that most of the disease relating to the mitochondria. Yeah. If we can improve the efficacy of mitochondria, reducing the level, that can positively influence the disease. So I think I opened the door, and there is a endless space behind it, and need scientists, people, pharma to discover and to figure out step by step where we can apply deuterium depletion and what will be the benefit if we involve it and use it.
Okay, that's great. Yeah, because I know really we're looking at dementia, we're looking at Parkinson's, Alzheimer's. So no one has done any studies on those diseases and deuterium depleted water that you know of yet. That hasn't been done. Yeah. Okay, well, it sure sounds like a pretty good market. There's a lot of people who could really benefit. Oh, fascinating.
So finally, the whole generation and population should educate, go to that direction, go back to the original food composition, reduce the carbohydrate intake, or consume DDW. I think it's necessary. Otherwise, the society will not able to cope with the cost, but the increasing incidence of cancer and so much diabetic disease and high blood pressure and all the thing. So 50% of the population will work on to finance the other 50% of the population who are suffering from different diseases. So it's impossible to live with that.
Okay. All right. Well, thank you so much. I really appreciate this podcast, and I know that I want to let you tell everyone where they can find your work. And I've read both of your books. I think they're very worthwhile. Everyone probably knows somebody at some point in their life who's suffering from or is diagnosed with cancer. So how can people find you?
We are everywhere. So people can find the HYD LLC in Hungary. This is the company name. The Preventa is the product which is available. On the ResearchGate site, people can find me. I'm also on the LinkedIn. I regularly post our paper, which has been published. Just recently published the breast cancer earlier, the lung cancer, to share the knowledge, and waiting for investors, pharma companies. Without these, we cannot proceed. It's clear.
Waiting for somebody smart to recognize something very important, I think.
Yeah. Right.
All right.
Yeah.
All right, great. Okay, well, thank you. We'll end it there.